Musicians have developed many shorthand ways of notating music. Shorthand notation methods are used to save ink or to make reading music less burdensome. Figured bass is one such way musicians use a shorthand music notation. Figured bass is a bass line with numbers and other symbols below it that represent information such as chord members, inversion, and chromatic alterations. Figured bass was originally used by keyboardists in the Baroque period. It offered a skeleton above which the keyboard would create or realize the chords above the bass line based on the information provided in the figured bass. Let's look at what figured bass looked like back then. Here is an example of a figured bass line for a keyboard part that accompanies flute in a sonata by J.S. Bach. There are bass note pitches and numbers, or figures, that tell the performer what types of chords to create above each bass note. Here is what this score looks like in modern notation with the addition of the flute part. You can see the bass line and the figures below it. The keyboard performer would have to create an accompaniment using this given information. Figured bass is kind of like the reverse of a lead sheet. A lead sheet specifies the essential elements of a popular song: the melody, lyrics, and harmony. The melody is written in modern Western music notation, the lyrics are written as text below the staff, and the harmony is specified with chord symbols above the staff. To understand what all of the numbers and symbols mean of a figured bass, it's best to look at a completely realized piece of music and then reverse engineer it to show how we would write the figured bass for it. Here is a chorale for 4 voices. It is in D major. Here's what the chorale sounds like. First, let's create what I like to call a macro analysis. This type of analysis involves determining the root, quality, and inversion of each chord. The macro analysis can take many forms, but I prefer to write it like chords on a lead sheet or guitar tablature. The first chord is a D major triad in root position. For our macro analysis, we would write this as an uppercase D to represent the root of the chord. The second chord is also a D major triad, but in first inversion. We still write an uppercase D, but show the inversion by adding a forward slash and the pitch that is in the bass, in this case, F sharp. The third chord is an E minor triad in first inversion. To denote a minor triad, we still use an uppercase letter, but we add a lowercase m next to it. We show the inversion with a forward slash and the pitch in the bass, G. The next chord is a D major triad, but now in second inversion. We write an uppercase D, a forward slash, and the pitch that is in the bass, A. The penultimate chord is an A major triad in root position, and the last chord is a D major triad in root position. We indicate both of these chords with a single uppercase letter. As a side note, if a triad were diminished, you would indicate it with an uppercase letter and the abbreviation DIM. If it were augmented, you would indicate it with an uppercase letter and a superscript plus sign. By completing this task, we have a complete understanding of the pitch content, quality, and inversion of every chord. Now we can turn our attention to reverse engineering the figured bass. We are going to look at each pitch of the bass line and identify the generic interval between the bass note and each note written above it. On the first chord, the note in the bass voice is the pitch D. The pitch in the tenor voice is D, 1 octave higher. The generic interval size for an octave is 8, so we place an 8 below the bass note. This is where figured bass symbols are indicated. The next highest pitch is the F sharp in the alto voice. It is an F sharp because of the key signature. The pitch is an octave plus a generic third higher than the bass note D. An interval that is greater than an octave is called a compound interval, so this is referred to as a compound third. A simple interval is an interval that is 1 octave or less in size. For figured bass, we will indicate the generic interval as a simple interval. So we will just indicate in our figure that there is a generic third above the bass note present in the chord. The distance between the bass and the pitch in the soprano is a generic compound fifth. Again, for figured bass, we just indicate the generic simple interval size. Note that the numbers in the figured bass are stacked from highest to lowest. Let's look at the next chord. The tenor is a sixth above the bass, so you put a 6 in the figured bass. The alto is a compound third above the bass, so we put a 3 in the figured bass. The soprano is a compound sixth above the bass, so we put another 6 in the figured bass. Let's look at the third chord. The tenor is a third above the bass, so we put a 3 in the figured bass. The alto is an octave above the bass, so we put an 8 in the figured bass. The soprano is a compound sixth above the bass, so we put a 6 in the figured bass. We can repeat this procedure for the remaining chords. What we have created here is a figured bass with all the intervals indicated, but figured bass is supposed to be a shorthand notation, so we can remove some things from the figured bass that are duplicated or implied. First, we will almost always double the root of the chord when writing for 4 voices, so we can remove any of the figured bass numbers that represent a doubled pitch. Next, having a third in the chord is always implied. Without the third of a chord, we couldn't identify the quality, so we can remove any of the figured bass numbers that indicate the third of the chord. Next, having a fifth in the chord is also always implied. So just as we deleted any figures that represented the third, we can do the same thing with figures that represent the fifth. What we are left with is a reasonable number of figures. Let's compare our bass figures with the macro analysis. The second and third chords are both in first inversion. The fourth chord is in second inversion. Look at the figured bass for these chords. Both first inversion triads have a 6 in the figured bass. The second inversion triad has a 6 and a 4 in the figured bass. This pattern could continue for any triad in these inversions. So, relating this to figured bass, whenever we see a 6 in the figured bass, that means build a first inversion triad above the given bass note. Whenever we see a 6 and a 4 in the figured bass, that means build a second inversion triad above the given bass note. Notice that the rest of the remaining chords are in root position and have no figures in the figured bass. Whenever you have a bass note without any figures below it, that means build a root position triad above the given bass note. We can combine what we know about the macro analysis and bass figures to add additional information to our Roman numerals. Transfer the figures that indicate inversion to your Roman numerals from now on so that each Roman numeral explains the quality, inversion, and relationship to the tonic for each chord. So now that we have completely reverse engineered our figured bass from the chorale example, let's see how this example would look just as a figured bass. A keyboardist would read this figured bass, which consists of just the bass line and figures that help identify inversions. This skill involves both the ability to read and understand the bass line and figures, and the ability to improvise. It's important for you as a musician to understand this technique for several reasons. First, when you perform music that comes from the Baroque time period, you can now appreciate the fact that music publishers have created realized versions of the piano parts for us. On the other hand, you can also refer back to the original figured bass version to determine what you think is the best realization. This also helps us to understand where the symbols that we use to indicate inversion in Roman numeral analysis come from. It can also be a great shorthand method for you when analyzing or composing music. Music is not just made up of triads. We can also have seventh chords. This example contains all inversions of the major minor seventh chord built on the dominant in the key of D major. Each chord contains the same pitches: A, C sharp, E, and G. The first example is in root position. On a lead sheet, if the chord is in root position, as in this first chord, we would notate it as an uppercase A with a 7. In fact, note that all of these chords begin with the same lead sheet chord notation, A7. The second chord is in first inversion. We notate this on a lead sheet by adding a / and the bass pitch C sharp. The third chord is in second inversion, so we add a / and the bass pitch E. The last chord is in third inversion, so we add a / and the bass pitch G. If we add a complete figured bass that represents every interval on which a pitch is built above the given bass note, it would look like this. We can do the same thing as we did with the triads and remove any indications that are implied, such as the third and the fifth of the root position chord. We also remove some sixes from the second and third inversions so that we don't have to write as many figures. Now we have the figured bass that we would see for any seventh chord in root position or any inversion. All first inversion seventh chords will use the figured bass 6-5. All second inversion seventh chords will use the figured bass 4-3. And all third inversion seventh chords will use the figured bass 4-2. We can also apply these figures to our Roman numerals to indicate inversion. Finally, we can show a chromatic alteration of any pitch by adding some additional symbols, such as a sharp, flat, natural, or a slash through a number. Right now, we will only see these types of alterations when in the minor mode, because alterations need to be made to the 6th and 7th scale degrees. The sharp, flat, and natural will raise, lower, or return a pitch to its regular state, respectively. If an accidental is all alone, as in the first chord, it means to alter the third above the bass. A third above the bass note D is F sharp because of the key signature. But the natural in the figured bass tells us to change that pitch to an F natural. An accidental next to a number alters the pitch at that generic interval above the given bass note. In the penultimate chord, we see a flat next to a 5. This means to find the fifth above the bass note and to lower it 1/2 step. The bass note is A. A fifth above A is E. We need to lower it, so we've added a flat to it. Finally, a slash through any number is similar to a sharp. The third chord has a /6 in the figured bass. That means that you should find the sixth above the bass note and raise it. The bass note is G. A sixth above G is E. We need to raise E by 1 semitone. In this case, we do so by adding a sharp. To summarize, a figured bass is a bass line with accompanying numbers and signs that tell a performer what chords to create above that given bass line. Chromatic alterations are shown with the addition of symbols to the figured bass numbers. To determine what pitch is altered, find the interval above the bass note indicated by the number in the figured bass, and alter the pitch according to the accidentals or slashes. We will continue to use figured bass throughout many of the remaining concepts in music theory.